Welcome to another quiet journey through the mysteries of the universe. Tonight, we drift slowly beyond Earth, beyond the moon, and into deep calm of our solar system to explore a strange and fascinating question. Why do some planets spin the wrong way? Scientists have spent decades studying the silent dance of planets, moons, and stars, and what they discovered is both surprising and beautiful. Some worlds rotate in the same direction as their star, while others seem to move against the cosmic flow, almost as if they ignore the rules entirely. As you settle into night, imagine yourself floating peacefully through space, surrounded by the soft glow of distant planets, turning slowly in the dark. This is science to sleep by, where the curiosity meets calm and where even the strangest questions become gentle stories carried through the stars. The story of planetary spin begins more than 4.5 billion years ago, when our solar system was nothing more than a giant cloud of gas and dust slowly drifting through space. Scientists believe this cloud, called the solar nebula, began collapsing under its own gravity. As it collapsed, it started to rotate much like a figure skater pulling in their arms to spin faster. Over millions of years, tiny particles collided and stuck together, eventually forming planets. Because everything in the solar system formed from this rotating cloud, most planets ended up spinning in the same direction as the Sun. Earth spins this way, Mars spins this way, and Jupiter does too. Astronomers call this prograde rotation. Yet, not every planet followed the pattern. Venus rotates backward compared to the other planets, and Uranus spins almost sideways as though it had tipped over long ago. These unusual rotations puzzle scientists for centuries. Today, many astronomers believe violent collisions every in the solar system's history may explain these strange movements. During the chaotic formation of planets, enormous objects crash into one another constantly. Imagine worlds colliding in darkness, each impact powerful enough to reshape an entire planet forever. Researchers think Venus may have experienced massive gravitational disturbance that slowly reverse its spin over billions of years. Uranus, meanwhile, may have been struck by the Earth sized object that knocked it onto its side. NASA scientists studying planetary formation often describe the early solar system as a cosmic pinball machine where giant impacts determined the future of the world. These ancient collisions changed not only how planets spin, but also how long their days last, how their climate evolved, and perhaps even whether life could emerge. Earth itself may have experienced such a collision when a Mars sized body struck our young planet, eventually forming the moon. Yet, Earth recovered into a relatively stable rotation, while Venus and Uranus carried the scars of Jaws forever. In quiet darkness of space, every spinning planet tells the story of ancient violence hidden beneath the calm skies. As scientists continue exploring the solar system, they realized that planetary spin affects nearly everything about our world. Rotation shapes, weather patterns, magnetic fields, temperatures, and even the length of a day. On Earth, one complete rotation takes about 24 hours, creating the familiar cycle of sunrise and sunset that guides life itself. But Uranus rotates so slowly that one Venusian day lasts longer than its entire year. Imagine standing on the surface of Venus and watching the sun crawl slowly across a thick orange sky for months at a time before darkness finally arrives. Scientists using radar mapping from missions like NASA's Magellan spacecraft discovered that Venus spins clockwise opposite to Earth's counterclockwise motion. Some researchers believe the planet's dense atmosphere may have played a role in slowing and reversing its rotation over immense periods of time. Others suggest repeated asteroid impacts gradually altered its movement. Uranus presents an even stranger case. Its axis is tilted by about 98 degrees, meaning the planet essentially rolls around the sun like a giant spinning ball. During parts of its orbit, one pole faces the sun for decades while the other remains in darkness. Astronomers think only a catastrophic collision could create such an extreme tilt. These unusual spins remind scientists that planetary systems are not perfectly orderly machines. Instead, they are dynamic systems shaped by the chance, gravity, and time. Even beyond our solar system, astronomers using powerful telescopes have discovered exoplanets with bizarre rotations and extreme environments. Some worlds may rotate incredibly fast, creating violent storms across their atmospheres, while others may barely rotate at all. Researchers at institutions like the California Institute of Technology and the European Southern Observatory continue studying these distant planets to better understand how worlds form and evolve. Every discovery adds another piece to puzzle of cosmic motion, and perhaps one of the most comforting truths in astronomy is this: the universe is not rigid or perfect. Worlds can tilt, spin backward, wobble, collide, and still continue their endless journey through space. There is also something deeply human about our fascination with spinning planets. For thousands of years, people looked into the night sky and wondered why the heavens moved the way they did. Ancient civilization carefully tracked the motion of planets across the stars, believing their movement held meaning and mystery. Today, modern science has replaced myths with mathematics and observation. Yet the sense of wonder remains the same. When astronomers study a planet spinning the wrong way, they are really studying history written in motion. Every rotation contains clues about ancient impacts, hidden interiors, gravitational forces, and billions of years of change. Scientists often compare planets to time capsules, preserving evidence from earliest days of the solar system. Space missions continue helping us unlock these secrets. NASA's Voyager spacecraft revealed Uranus in extraordinary detail during its flyby in 1986, while future missions may someday explore Venus's atmosphere and surface more closely than ever before. Researchers hope these missions will answer lingering questions about how planets evolve and why some worlds become stable while others remain extreme. Yet, beyond the science, there is a quieter lesson hidden among the stars. The universe doesn't demand perfectly alignment. Some planets spin differently from the rest and still they remain part of the same cosmic family, circling the same sun in silent harmony. In a way, the strange rotations of Venus and Uranus remind us that difference is not disorder. Nature allows for variation, unpredictability, and surprise. And perhaps that is why space feels so endlessly calming to think about before sleep. Out there in the vast darkness, planets continue turning slowly in every direction imaginable, untouched by hurry or noise. Their movements unfold over billions of years, far beyond the pace of human life. Tonight, as the Earth carries us gently through space at more than 1,000 miles per hour, remember that we too are part of this grand celestial dance. Above us, beyond the clouds, worlds spin quietly in dark, even each one following its own path through the universe. There is another fascinating idea scientists continue to study when discussing unusual planetary rotation, and it involves something almost invisible: gravity itself. In space, gravity is not simply a force that pulls objects together, it also shapes movement over incredibly long periods of time. Astronomers believe that the gravitational influence of nearby planets, moons, and even the sun can slowly alter the spin of world over billions of years. This process is sometimes called a tidal interaction. Earth experienced a mild variant of this effect with our moon. Long ago, Earth rotated much faster than it does today, but the moon gravity gradually slowed our planet's spin. Scientists estimate that hundreds of millions of years ago, a day on Earth may have lasted only about 18 hours. The same invisible forces may have transformed other planets in far more dramatic way. Venus, for example, sits close to the sun and is wrapped in an extremely dense atmosphere that traps heat and creates enormous pressure. Some planetary scientists suggest that combined effect of solar gravity and atmospheric tides slowly reversed Venus' rotation over immense stretches of time. Rather than one catastrophic event, its strange backward spin may have developed gradually like a clock slowly turning in opposite direction. This possibly fascinates researchers because it locked into permanent behavior. They continue changing long after their formation. Even giant gas planets like Jupiter and Saturn influence one another through the gravitational resonance, creating subtle effects across the solar system. Beyond our own cosmic neighborhood, astronomers observing distant exoplanets have found evidence of worlds orbiting so close to their stars that one side permanently faces daylight while the other remains trapped in endless night. These planets may rotate differently because of tidal locking, a process where gravity synchronizes a planet spin with its orbit. The moon itself is tidally locked to Earth, which is why we always see the same lunar force from our planet. Researchers using advanced telescopes such as James Webb Space Telescope hope to uncover even more strange rotational pattern in the years ahead. Every new discovery reminds scientists that the universe is filled with worlds shaped by forces both violent and gentle, sudden and slow. And somewhere in the endless silence of space, planets continue turning patiently through darkness, guided by gravity's quiet and unstoppable hand. Another mystery surrounding planetary spin involve the hidden interiors of planet themselves. Deep beneath thick atmospheres and frozen surfaces, scientists believe powerful internal forces may influence how planets rotate over time. Earth, for example, contains a molten outer core made mostly of liquid iron and nickel. As this enormous metallic ocean moves beneath the crust, it generates Earth magnetic field. shielding our world from the harmful solar radiation. As we drift toward the end of tonight's journey, the strange backward spin of planets remind us that the universe doesn't always move in perfect patterns. Some worlds quietly turn against the follow, shaped by ancient collisions and forgotten movements from billions of years ago. Yet even in their differences, they remain part of same calm cosmic dance circling their star in silence beneath the endless dark, so as stars continue their slow motion above. Allow your mind to wander peacefully through the universe and let quiet mysteries of space carry you gently into sleep. Thanks for watching my videos on my channel Science to Sleep By. Good night.